Alright, time for another DraftPhysics.com. DebatePhysics.com also, but very few people willing to engage in conversation regarding the basic elements controlling the function of the universe. The standard model, quantum mechanics, and the relativity theories. Yes, people just will not pay any attention to any conversation about any of that junk might be. Just that junk. So, physics says it takes 100 times the energy to spin a motor 10 times as fast. They say it. They produce zero evidence of it, and they just say believe it, even though it's ridiculous and silly. And that's really sad. And people defend that physics and say it's perfectly fine. It's gotten all the right answers I need. I have my smartphone, and my smartphone was invented by the Higgs boson, so without the Higgs boson, we certainly wouldn't have a smartphone. Some kind of crap like that, and that's fine. So it's all very, it all smells like Sasquatchian, in search of. Yeah, it sounds like the show In Search Of, frankly. Just a bunch of silly crap. And lies. They just lie about who Isaac Newton was and what he believed and what he discovered and what he did a ton of experiments, and they just don't care. And they just slander one of the most, you could say, devoted scientists in the history of mankind. Really did just spend all of his time thinking about these questions, pondering solutions, and he was successful at it. He did a good job. And they'll just slander him. Shove a bunch of crap he didn't believe in. It's like putting a bunch of Pokemon figures on top of his image or something. It's just a pathetic insult to the integrity of the work he did. And people are so despicable they don't care. They'll poo on a great man's grave, for a piece of candy. I don't even know what they're getting out of it. What are they getting out of it? Preserving the notion of what? So for many, they're not getting anything out of it except they wish to attack me. Okay, they don't like what I say, and they don't like the conclusions I've drawn regarding some subjects, and so to besmirch me, to create a smeared and ugly image of me. They need to do that because if I'm right about one thing, I might be right about some other things, and they can't have that being the truth. So they're just in it to, in some way, degrade my public in some way, say that, taint it in some way. That's it. That's all they want to do. But anyway, that's where we are. So I'll read some crap, that should. So it really won't matter, right? I mean, I played the Susskind video where he's using the water analogy, kind of clear. He's using a hydraulic analogy to explain the function of gravity. It doesn't matter to these people. They'll still say, oh, you can't use this water flowing or photons flowing or streams flowing or anything flowing as an example of gravity, even though, again, their top scientist, frankly, on the subject does exactly that. And then I can just keep reading little quotes from Newton, and it won't matter. They won't say, oh, yeah, well, of course Newton didn't believe what Leibniz believed. Of course, they believed different things. That's why there was a controversy. It's because they didn't have the same belief. And the truth is that from both perspectives, there are free energy formulas. So somebody has to be right and somebody has to be wrong, because they're not compatible formulas. They directly come up with directly different answers to the same question. All right. So leave us do that, and then we'll go on to a Understanding with Dave video. So a teacher who is a belligerent liar. I mean, frankly. The last video I made points out all these problems with MGH, with any notion of a v-squared velocity being correct. He ignores all the arguments and just makes another propaganda video shoving the same crap into the minds of little kids. lying to kids. I don't know why people find that enjoyable, but whatever. What's the incentive? To destroy the future. Yeah, that's it. What else could they want to accomplish? All right, so this is Newton, quoting Newton. When a body is falling, the uniform force of its gravity acting equally impresses in equal particles of time equal force upon the body. Okay, so he's saying it kind of clearly, all right, that time decides how much force you got. So I have drawn this so many times. And again, it's just Newtonian physics. I mean, Galilean physics, frankly. Galileo is the one who discovered the truth of it. All right, and so you can drop something a distance, and it will gain a velocity. And no matter what I drop, it's going to gain the same velocity. So it's about the force is collected based on your mass. So the hammer hits the ground with a lot more force than the feather, but they fall at the same time. And it's just that the hammer has a bigger sail. It has a bigger, whatever you call those things in a boat. It collected more force. And so this is a unit of time right here. Okay. And this, obviously, is exactly the same thing as this. So these two things are exactly the same thing. So yes, this time is the same as this time. And the other, 3 units of distance that you're going to fall in 1 unit of time, it's still just 1 unit of time. It's just because you're going faster. You're going 9.8 here. So you have accrued a velocity, and now it's going to give you just one of these. So this will be the new one you get for this unit of time. These two, okay, you're getting for free from this. Okay, the 9.8 means you're going to do these 2 units of 4.9 in distance. 4.9 in distance. So it's 9.8 in distance here. Okay, so that's 9.8 meters. You get that for free because your velocity is 9.8 here. Okay, so that's the velocity you gained. So it's kind of adds up. You just have to understand this 4.9 thing, okay, and understand that's how many meters you get per second. So we know how much velocity you get per second, but this is how many meters you get per second. It doesn't matter. You get the same number of meters no matter how fast you're getting. The new meters will be exactly the same. And the old meters are just what you accrued from your previous velocity. But the new energy is just this. The new energy is just producing 1 unit of 4.9 meters every 1 second. So this is the new one you get. We'll put a new here. And these are the 9.8 you got from the velocity. And so it all adds up. And this whole thing here is just 1 second. 1 second. 1 unit of time. So Newton's saying you get 2 units of force, which exactly comes out because you end up with a velocity that's 19.6. So obviously you only got 2 units of force. So why would somebody think you have 4 units of energy? That's right, no good reason. Absolutely 0 good reason. Nothing but bad reasons to think there's somehow 4 times the energy. When clearly, as Newton overtly states, you only got 2 units of force in these 2 particles of time. 1 unit of force per particle of time. All right, I'll read some more. All right, so I'll read that over again. When a body is falling, the uniform force of its gravity acting equally impresses in equal particles of time equal force upon the body, and therefore generates equal velocities, and in the whole time impresses a whole force that generates a whole velocity proportional to the time. So that's essentially the same as saying dependent on the time. So you want to know how many units of force you got? You just say how many seconds was it. If it's 9.8 meters per second, that'll tell you the answer. Okay, and when the body is thrown upward, its uniform gravity impresses forces and takes off velocities proportional to the times. Okay, so again, just making it clear. Newton understood it as a time-dependent force, not a distant-dependent force. Distance isn't telling you how much time you're in the force, and it's not telling you how much force is going to affect you. The time you're in the stream decides how much energy the stream gives you, not how far you drift in the stream. All right. So, will that impress anybody? Will they admit that Newton didn't believe what they're arguing? Will they at least make that argument that us modern physicists have debunked Newton? Will they say they debunked him? Will they say Newton was wrong? Do they have the courage and the integrity, instead of slandering him with bullshit accusations that aren't true, will they just say he was wrong? Do they have the courage to at least say that? These Goslings and Brozos and the rest of them, do they have the courage to say they know better than Isaac Newton? Okay. They've done better physics than Isaac Newton did. Go ahead and say it. Have the courage of your convictions, and out yourself as Leibnizians. You are not Newtonians. You are Leibnizians. That is your cult. You liars. You pathetic liars. All right, so this other bit of tripe was, the guy deleted the comment, but it's okay. I'm going to read it anyway. And I don't, nothing, no offense. You're entitled to delete your comment because it was crap. I mean, I was going to use the line, me no hablo fucktardo, because it's just so fucktarded. You can't even, it's this foreign language thing. It's okay. Okay, so you don't speak perfect English. You put in a translator. It comes out to be rubbish. Got it. I understand. But I'm going to respond to it anyway because it brings up some good subjects and might as well opine on them. So I've, tried to make this simple argument that there's no elemental wave function in the elemental universe because nothing is truly stuck to anything. So there's no mediums. There's no mechanism for it. So it's all just individual bullets flying around. And that, yes, when you take a bunch of bullets, I can draw it down here. You take a bunch of bullets and you can compress them. You can have a whole bunch here, okay, in these little places. And then when they hit the surface, it's going to go bang, 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 because there's a whole bunch of bullets coming, right? There's a bigger group of them here than there is here. Here there's 0, okay, and here there's a bunch. And then here there's 0, and here's a bunch. That's called a frequency, or there's a period between these events. And yes, you could call it a wavelength, but there's no waves here, okay? These could be bowling balls, cannonballs, it doesn't matter. There's no wave. There's no mechanism creating even the illusion of a wave. And let's understand, even a wave in a regular medium, okay, it's not really a wave. It's a whole complex thing that happens. The little atoms are sticky, okay? They're stuck to each other. So when one moves, they have to drag some other ones with them. And the whole idea of a water wave, for example, is that some of these atoms are pushing in this direction, and the water on this side is uncompressible. That is, that you can't smash them any closer to each other. So the pressure doesn't have anywhere to go. So it either goes this way or it goes this way. Now, obviously, the ground is really hard, so it can't go that way, right? But you actually see that it does, right? Now, when you have a sandy bottom to the ocean, you can see all kinds of ridges in that sandy bottom. So indicating that some of the pressure does go down. But anyway, the pressure realistically can't go down because there's high pressure of the earth pushing up. So it has to go into gravity. So it goes up. So the atoms go up. And then once they go up, there's, fuck you, I'm up in gravity. I can't stay up here. You're going to have to keep applying pressure for me to stay up here. And it can't keep applying pressure. So the pressure goes back down again. And the consequences is that just creates more pressure in this direction because it can't go back this way because there's more pressure this way. There's more pressure this way. So the only choice is to try to go this way again, and the same thing happens. And it just keeps doing it over and over and over again. So there's no wave elementally. Waves are emergent out of mechanisms that have adhesion to each other. So, stuff that is stuck, either magnetically, electrically, electrostatically. The stuff has to be connected to each other by some rubber band, some mechanism. And that stuff can create this illusion of a wave, but again, the wave is never going to be really a wave. It's a complex mechanical system that's creating the illusion of a wave. And clearly the argument is photons don't have anything to do with that. Force doesn't have anything to do with waving anywhere. It's just little bits. Okay, I shouldn't have drawn that up there with that there. I thought that problem was solved by this new strategy of mine. Apparently it wasn't. So I could have moved that up higher. Not that you need to read this, because it doesn't make much sense anyway. So do I need to say anything more? So I'm clearly stating there's two things in the universe. All right, there's matter, okay, electrons and protons. It's dead. It doesn't move on its own. And then there's this little stuff called force, okay? And the same thing that makes gravity makes photons. So photons are the force in a pattern. Like you could say they're running parallel to each other, say 3 of them, and they have a little bit of difference in their height. So it's like 3 parallel lines coming into a surface. One hits first, the second one hits, the third one hits. That's a photon when it hits a surface of atoms. This polarization is 1,000 atoms. So it's not like it hits one atom and then hits the same atom and then hits the same atom. It's not like it hits one electron. None of that stuff happens. So they draw these silly pictures of atoms with electrons, and then they draw a little squiggly photon popping out. Can't happen. Oh, you can't see that either. Should have just done that. I mean, we're not missing anything. Squiggly photons do not pop out of single atoms. Can't happen. All right. They're more complicated, and it's a pattern. Okay, so this is just a pattern of, energy, and it comes, in a pattern. Simplest pattern in the universe, really. Stuff, no stuff, stuff, no stuff, stuff, no stuff. And you can have any from radio waves to gamma rays in terms of how close this stuff is to each other. And you can sort of understand if it's really close to each other, then the same amount of time, there's going to be a huge amount of energy hitting something. And that the polarization would likewise get narrower and narrower. So as the energy of the frequency gets narrower and narrower, the polarization gets narrower and narrower, and that means it hits fewer atoms. So yes, it's even closer to hitting the same electron by the time it's a gamma ray. All right, but that's making it, don't need all that detail. And then magnetism is just the pattern, okay, except now the pattern has a more complex shape. So the bits have a plus and minus nature. So this could be a blue center of the bullseye, okay, you can understand it. Or I could have a hollow bullseye, okay, where the dark section is right here. Okay. So you can understand those are 2 different bullseyes, two different signals being sent, and that the other objects in space could see the different signals and react to the different signals with an opposite reaction. In one case it moves towards, the other case it moves away because it's getting hit versus not getting hit. So I've explained all that stuff. But anyway, so it's all mechanical. There's no waves in here. There's just bits hitting each other. Now look, the atoms are connected to each other. They are sharing electrons. So you can understand how when something happens to one of them, it ends up sharing the information with the other one. So you could argue there's some wave function. So an atom gets hit and its shape changes. Well, the one next to it, its shape changes a little bit too. And the one next to that now, its shape changes a little bit too. So the force of the impact does move through the atoms. You could argue there's a little bit of a wave function there, but again, the wave is made out of a mechanical process. The wave is not elemental, it's emergent. All right, that's probably enough of that. All right, so we'll read some of this. You gave a few talks debunking the silly light is a wave. That's a period. Yes, yeah, I've been doing that for 10 years, frankly. For 10 years, for 20 years, frankly, I've been saying the double slit experiment is a pile of crap. There's no waves. There's no freaking superposition. There's no entanglement. It's all a pile of nonsense. I've been arguing it's the surfaces that are causing the effect since the very beginning. I didn't really understand what kind of mechanism to use 10 or 15 years ago, but I now do understand that electrons are constantly moving on surfaces, and it's the movement of the electron that is changing the direction of the photons. And it's changing pieces of the photon. it's taking pieces and breaking it off of the photon. So the photon is broken. And then you can put the photon back together. And that's what the polarizing film proves. You can break the photons so you can't see them anymore with the polarizing filter. And then you can slip another filter in between and you can bring back the photons that are gone. Yeah, the ones that are supposed to be non-existent all of a sudden can reappear because all you do is put them back in the right order, right back into the right frequency, the right phase of frequency. All right, what is the waving as a background media? So obviously I'm saying there is no background media. There's little bullets in space. Some of them have a pattern, some of them don't. Okay, so the ones that are your cell phone, yeah, they have a pattern. They have a frequency plus amplitude. So they have two kinds of patterns built into them. And they hit an object and the object vibrates, so to speak, with that frequency in a sense. And if it vibrates with the resonance of the atoms, that if it makes the atoms vibrate just right, it causes a cascade of energy that allows an electron to move, which ends up being electricity, and it's detected as a signal. If it doesn't do that correctly, it just hits and vibrates the surface, or reflects, of course. But there's nothing waving. There's just stuff with patterns. Torpedoes, bullets, cannonballs, baseballs, individual stuff that is no way connected to each other. I guess I should just illustrate this real quick. Now, I left a comment for him after his first comment because he brought up Michelson and Morley, and I was like, no, it doesn't have anything to do with this subject. So the point is that what I should have pointed out with the force bits that makes them different than matter, okay, is that they can't interact with each other. So if one of them's going in a direction this way, and this one's going this way, right? You can understand at this intersection point, what's really going to happen is, so let's just make this one X, and we'll make this one solid. All right. I guess I should have just left this one hollow. All right. All that's going to happen is the hollow one's going to end up going this way, and the solid one's going to end up going this way. So you can understand that nothing will change in the universe. Now, if they actually are solid, like they are different, you could say, yes, there's a change. Now the solid one's not going that way, and the hollow one's going that way. But we're saying that all the force bits are the same. So I was just using the color to make a distinction here. The simple truth is this one will go this way, and this one will go this way, and the universe will look exactly the same as if they missed each other. You'll have exactly the same output, which is something going that way and something going that way. So the output will be exactly the same. So the universe should just give up. So you couldn't tell the difference. So nothing can change. And it's matter that makes it possible, okay, for there to be, for things to change, because matter means this stuff won't go as fast. So when something hits matter, it's going to go a lot slower. So the universe is going to change substantially because the force is not going to be getting where it would have been. So the universe is going to change when it hits matter. Force hits matter because it can't do the same thing. The same outcome isn't going to be the result. The force isn't going to get where it should be. If the matter wasn't there, the force would be here. If the matter's in the way, the force is stuck here. So it just won't be the same universe. So matter, the electrons and protons, are what makes the universe change. Because they change the outcome of where the force would be by effectively slowing the force down. But obviously the force itself shouldn't be thought of as slowing down. It's just being delayed by having to do some extra work. I don't know how to best say that, but whatever, it doesn't matter too much. All right, so we'll read some more of this. That permeates equally in all directions. So obviously the force doesn't permeate as some sort of medium. It's not a bunch of things stuck to each other that all move when everything moves. There's not an ether. There's discrete little bits of force, and they're always going the speed of light except when they're pushing a piece of matter. So there's only in two states. A force bit can only be in two states. It's either pushing an electron or a proton, or it's freely flying in a direction in the universe. Those are the two states it can be in. That's it. All right. Proving gravity affects the bits of force. So there is no proof of that. So I don't even know where you came up with that. So that's your statement. Proving gravity affects the bits of force. So he brings up Eddington, which is just so ridiculous, right? Because I've made so many statements regarding what a big fraud the Eddington experiment is. So Eddington's solar eclipse, shifting the background target star, doing observation over again in greater detail. So there is none of this greater detail. There's a 1919 experiment never successfully repeated on Earth with an eclipse beyond the margin of error. And when they had the greatest, most perfect eclipse possible, 12 noon, perfectly blue skies over North America, they didn't even try to repeat the experiment. And NASA apparently has never attempted it from space. So we've been in space 50 some years, lots of satellites, lots of cameras. They never even tried it. You don't need an eclipse, and it takes 5 minutes, and you have 400 times better resolution. So I've been over this so many times. So this is just part of the fraud of science. They just keep talking about this Eddington experiment like it's well-established good science, when it's exactly the opposite. The guy points out in his own journal that his data sucks. It's 1/10 of the quality he was expecting. He was expecting 10,000 stars per glass slide. He got 1,000. A terrible degrade in the quality of the data. And yet these liars, these defenders of physics, won't man up and say, yeah, we shouldn't be counting that experiment as anything but garbage, and we should redo it well. And the place you do it well from is space, obviously. You could use Jupiter instead of the sun, and then you won't have to worry about a bunch of radiation flying off of the sun and causing scatter and a lot of other crap that could fuck up your results. Get a nice clear image. You could do it from, looking through the gravity of Jupiter, and they haven't done it. So in all this time, they've had it right there, 5-minute experiment, they won't do it. That's not good science. That's the definition of bad science. It can't get any worse, really. That's about as bad as you can get, except for faking the results. Not getting the results is just as big a fake. I mean, to have a perfectly doable experiment that you don't do, that's just as bad as just faking it, almost. All right. Also, redoing larger. So the Michelson-Morley, it's just such a nothing experiment, frankly, in the sense that you people don't even understand how a beam splitter works. The whole thing becomes such a silly conversation. We haven't talked about all the nonsense of Michelson-Morley or of the silly interferometry, the gravitational wave thing. So I thought of another argument about that. So I figure I'll bring that up. So he says, also redoing larger scale space for fine-tuning enhanced accuracy of measurements. Making it bigger isn't necessarily going to make it any better, frankly. You're trying to make changes based on the frequency of the light, the distance between, the nanometers of distance between the on and the off. All right, you really don't need a giant one to do that. But anyway, big triangles in space interferometer. So again, more nonsense, frankly. All right, the weird thing about LIGO, I was thinking. All right, besides the fact that the truth is, that LIGO doesn't, it made this interferometer, these tunnels, and the big lie, the big fake part is they don't sit there and, let's say they're 2 miles long. All right, we can get rid of this for good this time. So you have these 2 mile long things, okay, and you put a mirror at this end, a mirror at this end. All right, well, the nonsense part is that they don't just shoot it this way, bounce it off the mirror, and it comes back again. Now, what they do is they shoot it into the mirror and reflect it 800 times. So the 2 miles wasn't nearly long enough, right? That's what they say. So they bounce it back and forth, right? So it's bounced back and forth 1,600 trips, right? 1,600 trips into a mirror. That's what that means, frankly. It's 16 hits of a mirror. 1,600 times. It has to go into a mirror. And they have really no science, right? Their mirror is a foot thick. And they say that the foot thick mirror makes light reflect off the first atom. So somehow having a foot thick mirror makes the mirror more mirrory somehow, right? That's part of their science here. So because it's a real problem, right? You have this idea of a photon going into a hitting. So you have, especially from a particle theory, you'd argue, well, one piece of the photon might hit this electron on this atom. The other one might hit an atom way back here. The other one might hit an atom way back here. It's a real problem in figuring out how you get a reflection off a mirror because, what's the photon actually reflecting off of? And so it could be that, you have all this extra distance that you're going into the material. And all that extra distance is obviously making your path length longer. So even if it was 10 atoms, 1,600 times 10 atoms, and so, it ends up being 100, ends up being 16,000. Okay. That's a huge amount of atoms now that you've added to the arbitrary length. It could be 0 or it could be 16,000. You don't know how much extra time or distance it traveled. So it's obviously going to add a tremendous amount of noise to your signal. So, and then they still claim they can do all this stuff. Now, the other thing I'd say is they never tested this LIGO device, right? So they could do simple tests, right? They have this tunnel with a mirror right here dangled in a vacuum, which I'll also ask a question. So they have the mirror sitting right there, and all they have to do is swing a weight up here above it. So swing a 1-ton weight. And we know it has a gravitational potential, and if this mirror can detect gravity waves from billions of light years away, it certainly should be able to detect that weight swinging above it. They've never done a test like that. So we have no evidence this thing even can detect. Yes, it can detect certain vibrations because it is a very sensitive mirror, but detecting gravity waves, maybe not. So the thing I was thinking about was, the most expensive part of LIGO is the fact they had to make this tunnel and they made it airtight. So you bring up Michelson-Morley. I mean, Michelson-Morley isn't done in a vacuum. I mean, light travels pretty good right through the atmosphere. You can shoot a piece of light pretty far. It doesn't get totally consumed. So you almost have to wonder, why is it got to be a hard vacuum, not a soft vacuum? I mean, even if you did a softer, take out at least the water molecules, dehumidify the air, do some different things to make sure you don't have a bunch of particles floating around in the air. So purify the air. But why do you need a hard vacuum? I mean, light shouldn't have much problem getting through. And wouldn't both legs create the same basic deterrence to the photons? See, they keep pretending that somehow they're sending one photon, and the one photon is bouncing off this side, and they're comparing one photon to one photon. When no, they're not doing any such thing. There's no way they can do that. I mean, they send, and that's the other lie of it, right? I mean, they send in megawatts of energy start the beam, and by the time they finish, they ended up with 6 watts. So somehow this whole device is consuming a ton of the energy, and I would argue that most of that's being consumed by the fact that they don't even understand what a beam splitter is. So the irony is what I found on my porch is you can just take a piece of glass, all right, with moisture on its surface. So it has little beads of moisture on the surface, just from blowing on it. Not the stuff you can see, just, and you've got a perfect beam splitter. Okay, so you can just shoot the light in at a 45-degree angle, and you'll get half the light will go over here, and half the light will go straight through here. And you don't have to put any, it doesn't have to be half silvered. And the very fact that it'll do that, even without the moisture layer, okay, it'll still do like 25% and 75%. you'll still get a very high percentage of the light reflecting, which means it can't be a 50-50 mirror, right? I mean, it can't be 50-50 sprayed mirror, because if it was 50-50, then you'd get way too much reflection. So it has to be a proportional amount of extra mirror to get the extra 25 to go that way. So it's not, even that's all, it's all veiled in these deceptions. But the real truth is what do you think the damn mirror's doing? And what's it doing when there's water droplets on it, right? So the idea is quite simply, is that all you're doing is you're creating this kind of surface problem for the light to go through, right? So the light has to go through what essentially you could understand is a bunch of slit experiments. These are a bunch of slit experiments. And what's happening is on these surfaces, every one of these surfaces is going to end up breaking a photon, shooting a piece, 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 shooting a piece. And what do they get shot to? Well, they don't get shot in a straight line. So you can understand the light going here and reflecting is just fine. The reflection isn't a problem. If it reflects, the photon's intact, no problem. The light that goes through is going through all these slit experiments, and what's happening is that obviously, what do the slit experiments do? Well, they take light that should hit here, and they create this, okay, and this. Okay, that's what it does. So it spreads the light. So the light coming out of here isn't going in a nice, its function, okay, it's in a narrow little spot, and then what's happening to it is it's doing this. It's spreading. And so when they bounce it through the the mirrors and all the other stuff, it just keeps increasing the spread, right? And so one side's getting spread, and the other side's not getting spread at all. It goes through a whole bunch of mirrors, and then it comes back to be recombined. Okay, so this one didn't spread at all, but now it's going to go through the mirror. All right, so I have to get rid of all this. All right, so now this that didn't get spread at all is going to go through the mirror, and what's going to happen is, yes, now it's going to get spread because it's going through the two slit experiments, so it's going to get spread a little bit. And this one coming back is now spreading. All right, can't really draw that. And its spread is gigantic compared to this one's spread. And that's what's really creating the path length difference, is that obviously this straight line is less time than this spreading line, and that's what you're really combining. You're taking the spread of the two patterns and now combining them on top of each other. So these photons really didn't come here at the same time, and you're going to just recreate the pattern you actually created. Both of them have a pattern because both of them have gone through the slit experiment, so to speak. And you're just lining up the patterns, essentially. You're lining up two single slit patterns. All right. And it's the spread that is really you're measuring. So you're measuring how much you've spread photons through this interferometer. And that's giving you a pretty, it's a pretty fine ruler, but it's not doing the wavelength of light thing. All right. So enough on that subject, I guess. Yeah, but it's very interesting. All these subjects are really interesting. Physics hasn't paid any attention. We could talk about Stern-Gerlach. We can talk about all the experiments and how they've completely distorted the reasonable conclusions you could draw from the experiments. The experiments give you some information, and they preposterously expand on that information with all kinds of nonsense, and they don't admit simple things like, well, why does a plain piece of glass split the light? Why does that work? But it doesn't work unless you put moisture on it. You're not going to get the pattern. Why is the moisture necessary? They don't ask any of these questions. They just propagandize for their bullshit. All right. So I think I finished with his argument. All right. So again, he did retract the comment. So maybe he knew, well, he probably knew it was unreadable and illegible. But it seems to me it does have an accusation that somehow I haven't covered these subjects and pointed out how There is no elemental waves. It's a false notion to tell anybody they have ever found anything that waves elementally. Particles can look like a wave. Water molecules can look like they're waving, okay? But the individual molecules are not waving. They're moving in direct directions. It's like water swirling in a bucket. Yeah, we go back to Newton's bucket. I mean, all these experiments are just so, and they just don't pay any attention. What's happening when you spin water in a bucket? I mean, what's the actual process? Okay, and there's a real process, right? I mean, as the bucket spins, if I spin the bucket, you can understand that the water has electrostatic adhesion. So the water molecules start to gain motion. And what do? They gain motion in a specific direction. They don't gain motion in a curved path. They gain motion in one direction. This one gets pushed by the bucket and it gets pushed this way. All right? And then something has to happen to change its direction. It wants to go this way. Well, it goes this way and it hits the surface of the bucket, so it doesn't work. So its direction has to be changed again to this way, and then it has to be changed to this way, and then it has to be changed to this way. And so what's happening on the interior? So as the motion moves from the outside to the inside, and this part starts to spin, what's the arrow doing? It's pointing out. It wants to get out of the bucket. That's what it's doing. It's heading out. Every arrow ends up heading out, heading out, heading out. So of course there's a motion in the out direction, but nothing is being pushed by a force. There's no centrifugal force or centripetal force. There's no such thing. There's just its velocity in a straight line, and the straight line would push it out. But it can't get there because it keeps banging into all these other molecules, and it has to drag the ones that are stuck to it. And so the only reason why it doesn't just fly out is because it's not free to fly out. But if it could, that's exactly what it would do. It would just go in a straight line out. So the electrons and protons never fly in a crooked path on their own. They have to be forced to. Nothing orbits the Earth, okay, because it knows I'm supposed to go in a crooked line. Okay, it has to be constantly pushed by the gravitational force. Its straight line has to be constantly turned. So again, it's like an Eleasing argument. The real universe is Eleased. Okay, it's made out of a bunch of little straight lines. The real universe is made out of straight lines. There are no crooked lines in the real universe. A bunch of little straight lines. And yes, from our perspective, it looks round. But it's a deception, because the reality is nothing travels crooked lines. The only time you can make something look crooked is to hit something and hit something and hit something and hit something and force it to go crooked. I mean, this is like the push-pull argument. To me, it's just, I don't even know how people could call themselves a physicist and not understand the elemental universe is made out of straight line vectors. There are no crooked line vectors. There is no crooked, I know to travel crooked. Something doesn't have to force me to go crooked. I go crooked on my own. Nothing travels crooked on its own. All right. Let's see how many. Yeah, 43 minutes. Maybe we'll just leave it there and I'll do the other bad video in another video. Yeah. Or maybe I just won't bother. I mean, it's just so stupid that he would, it's a 4-minute nothing video. I mean, it's just, well, I guess I'll just do it. I mean, it calls it conservation of energy, and it's just the same bullshit. There's no conservation. If you transfer energy from a light thing to a heavy thing, you're not going to conserve anything. It's just a fact. It completely violates Newton's second and third law. I mean, this mv squared is nonsense. And it's been... The fact that you have no evidence that it takes 25 times the fuel to go 5 times faster is just such a glaring omission. If you're going to preach this crap, you ought to be able to prove it. Show a 10-ton train going 5 miles an hour getting annihilated by a 5-ton train going 10 miles an hour. Show the 10-ton train, the 5-ton train pushing the whole, crash in its direction because it has so much more energy. But they'll never do any of that.
AQA, A-level physics, conservation of energy.
So just absolute bullshit. There's no conservation of either momentum or energy in these experiments you can do. You can just detail the experiment. You can just show, no conservation. All right, so I could do the simplest ones, just reiterate them, okay, and show them again over and over and over. There'll be no counter argument that the universe is working some other way than I'm stating. And none of the cowards will show up to present any counter argument that has anything to do with reality. Okay, so the simple truth is I put bullets in a gun. All right, I put very light bullets in the gun. Same explosive. Okay, I get 2,000 joules of energy comes out. 2,000. Same explosive here. Do the same exact thing. Put bullets in that are 1,000 times heavier. Okay, and what do I get? I get 2 joules of energy out, 2 joules of energy out. And where's the conservation of energy? We know the explosion couldn't possibly have changed. Same exact explosive. How could these two experiments have this completely different measurement of the energy of the explosion? 4,000 versus 4. 4,000 equals 4. That's conservation of energy. That makes sense to somebody. That could be a possibility in reality. No, it's absolute nonsense. Same momentum here, same momentum here. 2 joules, 4 joules here, it's 4 joules here. Okay? It's the same answer. Has to be the same momentum. Has to measure the energy the same way. There's no excuse for these gigantically different measurements of the energy. I could do the ballistic pendulum. Oh, let me do that one. I mean, damn it, it's just so frickin' obvious. They're conceding the point. I shoot the speeding bullet with the 2,000 joules into the ballistic pendulum. What happens? Okay, the ballistic pendulum conserves the momentum. It says, yes, let's say it had 100 momentums. The ballistic pendulum says, yes, I get the 98. Okay, most all the energy moved, the whole big, giant, heavy ballistic pendulum in this direction. I perfectly conserved 98% of the momentum, and yet, because now I'm stuck with just 2 joules, I lost 99.94, according to Professor Lewin, 99.94% of the kinetic energy has disappeared. It's gone. So how can he make this argument? Conservation of energy. There is no conservation. It's completely gone. You can't come up with any excuse. You couldn't have shot clay to the moon. You couldn't have done any of that because you couldn't have 98% of the momentum still. Nothing can move unless something with momentum causes it to move. You have to use something's momentum to go somewhere. If I'm sitting here, something has to hit me that has momentum, and it has to give me the momentum. It can't keep it and give it to me too. We both can't have it. All right, so then we have the classic 5 times 10 tron. Do that one real quick. And we know it's just mathematical nonsense. All right, I got a 5 mass object going 10V. Okay, I just add another 5 mass. I could just pour water into it, whatever, it doesn't matter. And I end up with a 10 mass going 5V. Okay, this experiment has been done hundreds, thousands of times, completely, absolutely the truth. This is what happens. 1/2 the kinetic energy is gone. And yet you preserved 99.9% of the momentum is conserved. So you conserve all the momentum and you lost half the kinetic energy. So again, you can't say, oh, well, pieces broke off and it got hot and a bunch of other wattages happened and the ground vibrated and some other thing. You can't say any of that happened because all of the momentum is still here. You can't say a bowling ball crashes into a bowling pin and the bowling ball still has all of its momentum. The pin flies off with 25 momentums and somehow the bowling ball didn't lose any. You can't say something like that because it's retarded. It's physically impossible. It's nonsense. And yet their physics is based on it. And here I am, years later, still having to argue with people. Facts are just so obvious.
This is the last of the mechanics videos. Yeah, you got to the end.
So it just sounds like he really hates physics. Yay, I got to the end. Yeah, of reading the book, and yeah, I read the book, and you should pay me to read a book. I'm not a physicist. I just read books.
This is the bit of the specification.
Yeah, the specification. There's no specification here except, look, here's one of our stupid formulas, mgh, which doesn't get right answers. And here's the other silly one, E equals 1/2 mv squared, which also doesn't get correct answers. Okay. I mean, there's quantitative and qualitative application of energy conservation to examples involving gravitational potential energy. So again, the examples are just nonsense because he doesn't even say what the answers are, which are in fact incorrect. In the fact that they never measure the wattage. They never measure the actual joules produced to prove that any of this stuff actually happens. Kinetic energy and the work done against resistive forces. So just such nonsense.
And we're going to be doing, although quite a lot of this I've already mentioned in other videos.
Yes, and I responded to the crap.
The principle of conservation of energy.
And you ran away.
Energy cannot be created or destroyed. It can only be transferred into other.
Right, so it's just absolute nonsense. It clearly can't be transferred, okay? You didn't transfer your kinetic energy. It didn't happen. The momentum gets transferred. Kinetic energy, no transfer. The ballistic pendulum. Oh, so somehow I transferred all the momentum. I didn't transfer any kinetic energy. I mean, almost every bit of it got wiped out. Come on. This is just such garbage. Such irrational nonsense.
Forms. Now, in particle physics, we'll look at the relationship between energy and mass. But in terms...
I don't even know why he's saying particle physics. I mean, it's just too silly.
In terms of mechanics, the total amount of energy is constant. So a very, very simple.
So again, this is completely consistent with Descartes, Galileo, and Newton. That yes, you have to conserve the momentum. That's what you have to conserve. Momentum must be conserved. So I can say Professor Lewin overtly states it. Well, you can finagle. Nature can deal with kinetic energy one way or the other. It can throw it out here and we get wacky numbers. But nature can't finagle momentum. Those are his exact words. And it's actually true. It's the one thing he says that, yes, that is the truth. Don't fall for this fake kinetic energy nonsense. If you really want to know what's going to happen, see what the momentum is. You want to know what something's coming for you? Okay, the speeding particle, momentum. You have a choice, right? You have a single atom moving 500 miles an hour, or you have 1,000 atoms moving 1 mile an hour. Which one do you want to jump out of the way of? Well, kinetic energy says the one atom going 500. Momentum says, nah, the 1,000 going 1. That's the one you want to watch out for, because that's the one that's going to squish you. That's the one that has really more energy. So this kinetic energy theory is such a pile of crap. Again, their theory says that one cosmic ray, one helium nuclei crashing into the ionosphere has enough energy to blow up the Empire State Building. No, it doesn't. It's just so ridiculous.
GCSE kind of question. A man of mass 80 kilograms falls 5 meters. What energy transfer takes place as he...
So they just do their little math and that's it. There's nothing here. There's no proof that any of this actually has a consequence and a result. So nothing. He won't show that that's actually how much energy it has. So he's just going to say it got 4 units of energy when Newton says it got 2.
Falls, calculate his velocity when he hits the ground. So ignoring air resistance, what energy transfer? That means what kind of energy do we start with? What kind of energy do we end up with?
All right, so he just does the velocity, frankly. So he doesn't do anything but just find out the velocity. So yes, we agree that's going to be its velocity at impact. But you don't need this formula at all. You just do the MGT thing. You just tell me how much time it is, and you know how far you go in that amount of time. So in 1 second, you'll travel 4.9 meters. That's what you know. And you know that in 1 second, you'll have a velocity of 9.8. So tell me how long you're falling, and I can tell you how much energy you have. I don't need all this crap. I don't need any of that crap. All right, and then he does a roller coaster, and he's going to decide what the friction was. So he's going to make up fake numbers for how much kinetic energy, potential kinetic energy it has at the top, and then just make up a fake number about how much friction there is. When momentum can answer all these questions. You don't have to invoke any mv squared nonsense. And you do exactly the same thing. You just say what's the momentum here? And at the bottom you say, what's the change in the momentum? Well, whatever that is, that's how much you lost to the track in air. There's nothing, this is so rudimentary. Okay, but he's making a claim that it's in these joules, the energy, and it's not. If they actually measured the wattage, it's not going to be there. Because they have a false notion of what the energy was at the top, and they have a false notion of how much energy is left, and they have a false notion of how much energy went into the track. So you can say it's 1,548 newtons. He said joules. So I don't know why he has it in newtons. I mean, I can play that part. Maybe you can hear him.
Joules.
It just said joules, right there. He just said it. So I don't know why he's got the N there.
Energy, it's measured in joules. So mgh goes to...
So that doesn't make any sense either. It's measured in joules, but I wrote down newtons.
A half mv squared minus a half mv squared. That's the difference.
So you don't need any of the mv squared. You just need velocity. So you just say the difference is not its mass. Its mass isn't going to change. The only thing that's going to change is its velocity. The velocity change will tell us the momentum change. The momentum change is what the track ate. The track ate whatever you don't still have. And the last one he does is something where, if you lose your brakes on the highway, you can go up a little ramp and hopefully you'll lose some energy. A gravelly ramp. I imagine it's just thick gravel, so frankly you just plow into the gravel, frankly. So this is clearly not the kind of thing where you're going up a ramp and you're going to decide by how high you go up the ramp will decide how much energy you lost. It's more like you're going to plow into a bunch of gravel. It's going to pile up in front of your vehicle and slow you down. I bet you that's how it works. I mean, there'd be no point in having a launching ramp, right? I mean, if you're going 60 miles an hour and you go off this launching ramp, that's not going to save your life. So that ain't going to do you any good. So this is like water barrels. I mean, this is like just putting a whole bunch of stuff that you can move in front of you. So you'll move all these little rocks, you'll move them. Okay, and by moving all the little rocks, you end up dissipating all of your energy, giving it to the movement of the rocks. All right. So anyway, so yeah, totally none of it proven. He just does this fake crap math and says so. So he does the final one is a spring, a pinball machine kind of idea, shoot a ball. He tells us how much energy it is, never measured, no proof. And we already know from our conversations that if you're going to go any distance, 1.8 meters, you're going to go across a 1.8 meter track, you're going to end up losing a lot of velocity to the track itself. So you're not going to have the same velocity when you get to this ramp that you had when you started. All right. So just a junk video, absolute junk, garbage, trash, rubbish, unproven.
Have a go yourself.
Just a fake reality. This is nothing but religion being preached by an amateur, a really amateur and kind of pitiful preacher who really doesn't even understand the Bible. He's trying to interpret for his students. Yeah, okay. Oh, sorry, it wasn't playing. So yes, so the new camera angle has totally failed because, yeah, I didn't figure out that I'm supposed to have the video showing. So there's the off-rampy thing. There's the roller coaster thing. So there really wasn't anything to see there. So you didn't really miss anything. And this is the guy jumping off a building. So anyway, junk. Just absolute garbage. These people don't have enough integrity to defend this nonsense. Defend the fact that you are a Leibnizian, Dave. So, you should be saying understanding Leibnizian physics with Dave. Because it's not Newtonian and it's not good physics. It's not real and it's not accurate. It might as well just be some sort of variety of flat earth science, frankly. It's crap. It's no evidenced crap. There's just no evidence. You've had hundreds of years to acquire some evidence to support your theory, to support 1/2 mv squared, and you've produced none. You can't show me even it taking 4 times the energy to spin a motor twice as fast. You're never going to show me it taking 25 times the energy to go 5 times as fast, but you can't even do 4 times the energy to go twice as fast. You fakes, phonies, frauds, bums, creeps, liars. Pseudo things. You're just nasty bits. Yeah, you're a nasty bit. You're, just neuron molesters. Enough said. I like that. Neuron molesters. Okay, we'll go with that.